Off to the races. So I've been seeing a gray fox for sure, and they tend to den underneath tool sheds like this. And it's certainly been excavated considerably over the last recent years. Down underneath, it's all dug up, which didn't used to be the case. Okay, here's the bench that was in the other video, and the camera was sitting, back, maybe on this thing, but not quite, a little bit closer, like right about here. So, the bench was, and this was completely out of focus, and those bushes right here, these were completely out of focus, and whoa. There. I had no idea there was ice there. Yeah. Well, good thing this is a GoPro, and wow. I had no idea that water had collected there. Not any idea at all. When you're heading down, you just sort of kind of try to not land on any one thing. That's the trick. Don't land on your elbow, don't land on your wrist. Okay, so here's my power pack. Here's my camera. And the idea I have, if it'll fit, is to stick it right under here. Yeah, it'll fit. Okay, it's a bit of a tight squeeze. Okay, and then the power pack. Wow, yeah. I haven't fallen on my ass quite like that in quite a while. Alright. And hate wires. I always hate wires. Whenever I'm dealing with wires, you'll hear me complaining about them. I'm trying to get this up here where I can deal with it. Okay. Can get at that later. Okay. And just stick it right around back here. That should be alright. The last thing I gotta do is finish this job without getting myself totally wrecked. Alright, I'm gonna get in here and do this. Open the door. Turn on the power. Power's up. Alright. Alright, it's on. Look at this. No, I had no idea that water collected here. I had no idea that you could go ice skating back here. Good grief. Alright, well, I've certainly disturbed things. But anyhow, I've seen skunks going in and out under there, and I suspect that a gray fox may call that a den, and we'll see what happens. Alright, well, anyhow. Whew. The hazards of science. So far, we've pretty much confirmed that the camera behaves when it's still warm outdoors the way it did indoors. So the question is, what is the performance at lower temperatures? Here are the results for the half diopter lens. While the camera is still warm, the focus is about the same as we saw in the workshop test. When the camera cooled down, the focus increased with temperature. Now it's 5 feet to infinity in visible light. But the question is, what about nighttime? And nighttime, it's 6 feet to at least 16 feet, but I can't see beyond 16 feet. There's just not anything illuminated beyond that point. That's going to require some more testing. Okay, so here we are. Plainly, we had a lot of wind, but this camera is sort of out of the wind, or a little bit more out of the wind anyhow, down under the shed, and learned my lesson about walking on ice. I'm going to come in here really slow, real slow, see if I can avoid the disaster of not knowing there's ice. That's the worst. Okay, so here's my camera. Okay, so here's my camera, here's my lens. There's no roof on this one because it's down under here. Eventually I'll add that. Okay, so I'll get in here, open, turn it off, wait a second, 2, 3, I don't see anything going on. Alright, I'm going to take the chip out. It's cold out, it's like 25 degrees, windy. This is not fun weather at all. Okay, this is a 0.1 diopter corrective lens, by the way. Okay, we'll close that up. And I'm not sure what direction to aim this. I think, I don't know. I think I'll, just for a difference, I'll aim it this way. Kind of aimed up. I don't know if I want that. Let me. Okay, well, see what happens. Okay, so that's it for now. Oh, and this is my tripod, but I thought I would reward my animal friends and give them something to chew on while they're on screen. Here are the results for the 1 diopter outdoors. In visible light, we're getting 3 to 8 feet. And at night, we're getting 4 to, once again, 16 feet because it's not illuminating anything beyond that point. So once again, I'm going to have to find the maximum distance with another test. I'm here to do some serious measuring in order to, I'm laying out yardsticks, a whole bunch of them, end to end. I've got 10 feet, I want to get this exactly right. Current adventure is to go check up on the camera that's by the meter. You can see we had a fair amount of wind over the last 24 hours. And I've actually already checked up on this camera an hour ago, and it looks like it's intact. You'll see that the roof over the lens is intact. The rain shield wasn't blown away. And I looked at the videos, and the videos didn't have any rain or fogging. That's good. So, and generally I had the impression, okay, this is great, this is fantastic. But I have a really big problem. In fact, I can see it right here. I don't know if you can see it. See the gap? See the gap between the lens and the Velcro? The Velcro on the lens and the Velcro in back. Well, that evidently was letting a lot of light leak into the lens. Now, if you have an image right here, the camera stops way down because of the amount of light, so it wasn't seeing the problem. But at a bigger distance, looking out in this direction here, definitely a problem, definitely a major problem. So I need to find a solution here that does a better job of blocking the light from getting inside between the lens and between the corrective lens and the camera lens from these LEDs around the edge here. Alright, so that's another project. So we have a problem. We have a big problem. I was looking at videos from the lens, just the lens attached to the camera, and there's definitely a problem with light, IR light, leaking in from the LEDs that are in the vicinity of the lens. I figured this black Velcro, it'll block the light, but that light is leaking from the corners, it's leaking from somewhere, it's getting into the camera. I figure, okay, let's press the thing on a little harder. Oh, that didn't work. I looked at it some more, and I came to the conclusion that, okay, well, I need to do something more to block that light. I have to keep the light from getting in there somehow. Let's think about this. Let's put my engineering hat on, and let's try to figure out where that light's getting in and maybe block that light, keep it from getting into the lens. Okay, so I tried this additional piece of Velcro. It's a sort of a horseshoe shape, and laid it in there, and I figured, okay, well, this is a test right here, but I thought, okay, what I'll do is I'll sandwich that in between. It'll give me another layer of material blocking the pathway of the IR getting in from the LEDs up into the lens area. And I tried that. That didn't work, and so I went crazy and I made this huge block of Velcro, just totally encapsulated the lens inside Velcro, and put that on the camera and jammed it on and went and checked that out. And that was even worse. That was the worst by far. So I'm beginning to wonder, well, what's going on here? What is going on here? I have this massive amount of Velcro between the IR LEDs and the camera lens, and it's worse. The more Velcro I add, the worse it gets. So I had to put my physicist hat on and said, okay, well, there's something about Velcro that I'm just not quite getting. And I started looking at these videos. It turns out I looked at my gray sweater, and my gray sweater is white. It's absolutely white. It's like I'm a snowman. And so evidently gray, dark gray in IR is white. And then I had to look at the Velcro, and the Velcro is white. It's as white as the snow. It's as white as possible. So it seems that the Velcro, when I attach it in the vicinity of the camera lens and as a way of trying to block the IR light, it turns out that the Velcro is not blocking the light, it's acting like a sponge. It's soaking that light in. It's soaking it in, distributing it, and injecting it into the lens, into the corrective lens. So I suddenly realized that the problem is the Velcro. The Velcro is not blocking the light. The Velcro is actually drawing the light into the lens and distributing it. And so I need a completely different solution. I can use Velcro as a mechanism to attach to the lens. It holds the lens on just fine. but I can no longer depend on the Velcro as a way to keep the light from leaking from the IR LEDs into the lens area. I need something else. I need something that takes into consideration that that light is there and mechanically blocks it with something that is totally impermeable to light. It totally blocks the IR light. That's absolutely what I had to come up with. And so the next segment of the video, you'll see my attempt at this, and the next segment after that, we'll see some test videos. The whole idea of Velcro as a way of blocking the IR light, that was something that was fundamental to my design. That doesn't work. Velcro to hold the lens on, fine. Velcro to hold the rain shield on, fine. But Velcro as a way of blocking the IR light was not going to work, and I needed to come up with another solution. So that's where we're headed next. Here's my camera as it's currently configured. Here's a lens that goes here, and as I've already described, light is leaking in from these LEDs. Turns out that the only solution is something like this. This will block IR LED light. It'll block visible light. It won't block X-rays and it won't block gamma rays, but it will block just about everything else. All right. So what I did earlier is I took a piece of this material, and this is foil tape. This is aluminum foil tape. Well, okay. So just for sake of argument, what I did is I took a piece of foil tape, and I peeled off the back, and I folded it to produce this. So what I want to do, first of all, I'll take off my roof and get that out of the way. Got Velcro there. I think that's okay, but I need to get this out of the way, at least for the moment. Man, it really stuck on there nicely. Okay, I'll just save that. Because I think I'm going to end up putting it back in, or some of it. Okay. All right, so the idea is I'm going to take this, and I really don't, I mean, I'm not exactly sure, but the idea is to put it around like that, and then put foil tape, use this foil tape to stick it onto the camera. Ah, there we go. All right, so let me get this out of here. Okay. Alright, well, that's kind of blocking things, but okay, well, alright, this is probably the time-lapse section of this video. Okay, so I have not blocked any of the LEDs by doing this, which is really good. Okay. Here's the shield, cold weather nighttime shield blocking IR. We'll see if this works. This is plan like, who knows, D or E or F or G or something at this point, but it'll have to be dark and cold in order to test that out. Before I continue, I need to point out that I didn't test the 0.75 diopter lens. It splits the difference, and I didn't see that there would be a lot gained by testing that particular lens. Finally, we have the nighttime infrared lit long distance performance of the 0.5 diopter and the 1 diopter corrective lens. The 0.5 looks like it reaches as far as at least 50 feet. In the video, I increased the brightness of the image to try to see as far as I could, and I was seeing things that are in the neighborhood of 40, 50. It's in focus to the maximum extent of the IR lighting. The 1 diopter, however, it's pretty clear that the focus is somewhere between 25 and 35 feet. In focus at 25 feet and out of focus at 35 feet, so 30 feet, maybe a little bit more, something like that. To summarize the overall conclusions of this test, first of all, there's nothing wrong with the camera. It's designed for large animals, moose, elk, deer, wolves. So when you apply this camera the way it's designed, there's really nothing wrong with it. Even the cold weather nighttime performance is reasonable. 12 feet is reasonable. If you're looking at a moose, 12 feet is reasonable. Don't assume that I'm saying anything is wrong with this camera. What I'm looking at is a way to improve one particular thing, which is the second point here, which is I want to be able to improve cold weather nighttime performance. And it turns out that a 0.5 diopter will do the job. It'll pull that focus in closer, and as long as it's still cold, you'll continue to get daytime focus all the way out to infinity. So you could almost just put a 0.5 diopter lens on your camera for the winter, sort of your wintertime lens. The problem, of course, is that you need to add a metallic IR lens shield, but only at greater distances. If you're doing closer distances, things closer than 10 feet or whatever, you don't need that shield. The light from the LEDs is so bright it overwhelms the stray light coming in from the sides. The third thing here, it's a very simple way to add a lot of capability to the camera. Not everybody has a moose walking through their backyard, and there's lots of very interesting things you could conceivably record if you had a close-up lens to add to your camera. And so the system is simple and allows you to image things that are a lot closer.